looking at number 5. Okay, so again, we are multiplying. So give yourself your rectangular box. Split down the half, and then make sure you have 6 boxes in there. Okay, let's put our first binomial on top, 6x minus 4. Then my trinomial down the side, 2x squared positive 2x minus 1. Cool. All right. I'm just going to randomly call on people, so you better be ready. Get your calculators ready if you need them. 6x times 2x squared is going to give me what, Gabe?
12.
Beautiful. 12, and then I have 2 and then 3 x's, so 12x cubed. Let's see. Bella, what am I going to get? Negative 4 times 2x squared. Negative 4 times 2. Beautiful, negative 8, and then my x squared attached. Let's see here. Brayden, what are we going to get with 6x times 2x? 6 times 2.
12x.
Love it. 12x squared. 2x is there. Kaylee, what are we going to get with negative 4 times 2x?
Negative 8x.
Negative 8 with just 1x. Lily, what are we going to get with 6x times negative 1? 6x times negative 1.
Negative 6.
Beautiful. So we got negative 6x. And Tony, what are we going to get with negative 4 times negative 1?
Negative 5.
Very close. What's negative 4 times negative 1? 4 times 1.
So 4 times 1.
4. Positive. So then a negative times a negative. Positive 4. No x's attached. Beautiful. Okay, before I write it out with my finished polynomial, what ones can I combine? Or, better yet, what one should I write first? What one comes first, Gabe?
The 4.
Ooh, which one has my highest power?
12x cubed.
Beautiful. 12x cubed. Sorry, that question wasn't worded very clearly. Okay. What can I combine next? Where are my like terms in my boxes? Kaylee.
Negative 8x squared and 12x squared.
Nice. So what is negative 8 plus 12? Remember, when we're combining like terms, we're just adding and subtracting, whatever it tells us to do. So what's negative 8 plus 12?
20x squared.
Super close. I meant the negative plus 12, Bella. Positive 4.
I was not close.
That's okay. I was not
Just a
close.
little.
You were close-ish. If you think about all the numbers, you were very close. Okay, where are my other like terms? What else can I combine? Bella?
Negative 8 and negative 6x.
Okay, so now think I'm at negative 8. Subtract 6 more. Negative 8.
Negative 14.
Nice. Love that you included the x on that. Can't combine 4, so we just add them on the end. And boom. There's our finished answer. Super ugly, but it's an answer. Okay, so keep in mind, because now we're going to turn our page over and we're going to talk about some new things. Okay, we're graphing quadratics again, which you guys know how to do. But keep in mind about these highest powers and descending orders. That's going to come in handy. Okay, so flip your page over. Yes, you guessed it. We are graphing quadratics again. You're like, oh, I thought that would go away. Nope, it's never going away until you graduate. Then you probably won't ever have to do it again. Like, when are we going to use this in real life? Probably never. But you're going to use it today. Okay, so.
Wait.
Yes.
I recognize that.
Yes, you should recognize this. We know how to graph quadratics. Now we're just going to identify a few more pieces. So in our directions, it says, state the maximum number of turns the graph of each function could make. Then sketch the graph. State the number of real zeros. And you're like, turns, zeros, what? Okay, let's just remind ourselves how to graph these guys. Okay, remember these guys are written in standard form. Nope, I wasn't nice with our notes today. Standard form is the mean one. The ax squared plus bx plus c, where you actually have to solve for your vertex. Darn it. But that's okay, you guys know how to do that. Okay, well, we solve for the vertex. Let's write down that little baby formula. You guys should hopefully remember. Sound familiar? X equals negative b over 2a. You guys are like, ugh, yes, I remember this.
Oh.
Yep. Okay, so we need to identify A, B, and C for these quadratics. Now look at number 7. A, B, and C. What do you think? What do you think? Kaylee, what's my A, B, and C here?
Your x is a, there's this invisible 1. Your b is x squared, and ayo.
Where's the C?
Good question. Is 2 my B or my C? Look back here. If B has an X always attached to it, is 2 my B or my C?
Oh, your c.
It's my C. What had to be in front of the B to make it disappear? What did it multiply by?
0.
A 0. Oh, okay. So let's just make a note that B actually equals 0 here. That's why we don't see it. Okay. That might make things a little weird. That's okay. Let's try it out. Let's plug in our X for our vertex. X is equal to negative B divided by 2 times A. What did we decide B was? What goes on top?
0.
0 goes in my B spot. A is just that invisible 1 that we identified. Wait a second. What is 0 divided by anything? Just 0, right? Okay, so for our vertex, we know the X part is 0. Oh, we love 0. 0 is like an awesome number in math, because watch what happens. So now to find the Y, remember we take that X and we plug it in to where we see the X in our original function, right? So Y equals 0 squared plus 2. What is 0 squared? What's 0 times 0?
2.
0.
You're ahead of me. Eli, what's 0 squared, Kaylee?
0.
It's just 0. So what are we left with, Eli?
2.
Just 2. Oh, that wasn't that bad, right? Okay, we found our vertex. Let's go ahead and put it on our graph. We have 0 for my X up to 2. Who remembers our trick? Up how many over how many?
Up 1 over 1.
Nice, Lily. Up 1 over 1 on both sides. Up how many over how many?
Up 3 over 1.
Nice. 1, 2, 3 over 1. 1, 2, 3 over 1. Woo. Okay. Now, here's where this new stuff is coming into play. It asked for turning points and real zeros. So let's go ahead and identify what these are. Okay? Turning point. Okay, a turning point is exactly what it sounds like. It's where it's headed one direction and then it turns the other direction. You guys see how many turning points we have? It was headed down right here. Now it turns around and heads back up. How many turning points do we have?
1.
We just have 1. So our turning point is 1. We have 1 turning point. Okay. Zeros. Let's identify those guys. Zeros are where they hit the x-axis. Now look at this really carefully, you guys. If my zeros are where it hits the x-axis, do I have any zeros for this function? Does it ever come down and hit this x-axis?
No.
No. So we actually don't have any zeros for this guy. And that's okay. So our zeros are 0. We have no zeros. 0 zeros. That won't always be the case. So turning points, just one, right? Turned around right there, one turning point. Zeros, it didn't ever touch my x-axis, so we have 0 zeros. Okay, let's try that again, because I can see some, like, whoa, looks on your face. We're gonna skip 8 and 10, just for time's sake. Yeah, I made these notes, like, super long. Okay, so, first things first, let's identify A, B, and C, right? We gotta graph this guy. Somebody raise your hand, help me identify A, B, and C. What do you think?
Negative x squared is the A, right?
Mm-hmm.
B is negative 2 squared, and C is plus 1.
Love it. So my A would be -1, B -2, C +1. Sweet. So now that we know that, let's plug it into our little formula to find the x part of my vertex. X is -b divided by 2 times A. Okay, well my B is a -2. My A is a -1. What happens when I have that double negative on top? Turns into a what? Double negative turns into a positive. So we have 2 divided by 2 times -1 is -2. What is 2 divided by -2?
0.
Close.
Wait, 2 divided by 1.
Close. Not +1, but
Negative.
-1. Beautiful. So we have -1 for our x part of our vertex. We love 1 too in math. Okay, so we're going to take this -1. We're going to plug it in everywhere we see an x in our original function to find the y. So now I have y equals negative. And this is where you have to be very careful. If you have a calculator, get it out right now. I highly recommend one of mine so you can see what you're typing. Okay, we have negative x squared minus 2 times x plus 1. And we know that my x is -1, so put in -1 for both of those spaces. Okay, and this is where you can punch this whole thing into a calculator, but you just have to make sure it looks exactly like this. Negatives, parentheses, and all. So, let's go ahead and do that. I have, let's see, there we go. It was a negative, parentheses, -1, parentheses, squared, minus 2, parentheses, -1, parentheses, plus 1, and we get +2. This whole thing, when I punched it into my calculator, gave me +2. Again, just punch it in. Just make sure it looks exactly like that. Okay, let's go ahead and graph this guy. My vertex is at -1, +2, right there. Then we just follow our pattern, right? But wait a second. My A is negative, so am I going to go up or down?
Down.
Nice, good job. So now I'm going to go down 1 over 1 on both sides. Down 1, 2, 3 over 1 on both sides. Beautiful. Okay, so how many times does it turn around? How many turning points do we have? Just one. Okay, so for turning points, we'll just say turned around one time. No, that's good. So it turned around once. How many times does it hit my x-axis? How many zeros do I have? 2. And that's all we're asking for right now. So it turned once, and it hits my x-axis twice. So I have 2 zeros. Show me a fist of 5. I know how to find the turning point where it turns around, and I know that zeros are where it hits. That's the big concept for today. Cool, cool. All right, it gets way easier now. Let's look at 11 through 14. Are we given a graph this time? we're not. It says state the possible number of real zeros for each function. Okay, so here's the thing. How we find the number of real zeros? You're gonna be like, oh my gosh, it's that easy. It's the highest power you're gonna see in the function, meaning the highest exponent. Okay, so look at number 11. If we find the zeros by identifying the highest power, what is my highest power or degree here?
55.
Look at the exponents. Which one's my biggest exponent?
6x squared,
Look at the exponent.
x cubed,
Which is how many zeros do I have?
3.
Nice. And guess what? It's that easy. Okay, now it didn't specifically ask for this on your direction, but we are actually going to identify turning points as well. And here's the thing. The zeros is how high the degree is. The turning points is that number minus 1. So take your highest power, subtract 1. How many turning points do I have for this function? It's that easy. Okay, let's try that again. You guys are like, what? Okay, so for number 12, let's identify the zeros. And I think I'm misspelling zeros all these times.
6x cubed,
What's the highest degree? What's the exponent on it?
x cubed,
3, right? So we have 3 zeros. So how many turning points do I have? 3 minus 1.
2.
2.